Qu13c looks to be separate from the previous parts, unless you can see a connection. Here's h of x defined here. X is not equal to negative d, so there's no vertical asymptote. Find the expression of the inverse function. So usually replace h of x with y. Y equals 2x minus 5 over x plus d. And you can interchange the variables here or at the end. It doesn't really matter. The whole point is to rearrange this to make the input the subject. So I'm going to just rearrange this without interchanging the variables just yet. I'll do that at the end. It's just an IGCSE question really, and the idea is we're going to expand. We're trying to solve for x, so we get the x's to one side. We can get the x's to this side or to this side. I'm going to choose to leave the yd there and bring the negative 5 across to make it positive 5. I'm going to leave the 2x here and bring the yx over to make it negative yx. Less negatives flying around then. So that's yd plus 5 equals, factor out the x, 2 minus y, and therefore x is equal to yd plus 5 over 2 minus y. And then just always write it in functional language. So the inverse function of g, that's wrong, that's actually h, not to worry. The inverse function of h is we take an input, we times it by d, take an input, times it by d, add on 5 and divide it by 2 minus input. So there's the inverse function. Part 2, interesting. Find the value of d such that h is a self-inverse function. Well, a function is self-inverse if the function itself is identical to its inverse function. Yeah? The classic example is y equals 1 over x. Now obviously if you sketch 1 over x, I'll just, for positive values of x, you have this, and it is a reflection in the line y equals x, so the function is a self-inverse. Okay? So we just have to solve this equation really. You've already got an expression for h of x up here. You've got an expression for the inverse function of x here, and you just have to make sure the two are actually equivalent. Okay, so let's just compare. So comparing, we need dx plus 5 over 2 minus x to be identical to 2x minus 5 over x plus d. Now I suppose the technical way to do it would be just to do a bit of cross multiplying, expand, and just compare coefficients on both sides. The x squares on this side match the x squares on this side. But just by inspection, you can clearly see that the d here has got to turn into something to do with 2. The x here has turned into negative x here. So what if we made d equal to negative 2? Yeah, if we made d equal to negative 2, the right hand side would be 2x minus 5 over x plus negative 2. And the left hand side would be negative 2x plus 5 over 2 minus x. But these two expressions are actually identical here. Times the top and bottom by negative 1, and the right hand side is left hand side. So I think that's absolutely fine just to do that answer by inspection. But if the question became a little bit tougher, then you do a bit of cross multiplying. You'd compare coefficients of x squared and compare coefficients of x. Okay. And if we move on to the last part, for this value of d, okay, so we're taking d equals negative 2. It's a bit unfortunate if you couldn't get d equals negative 2 out from the last part, it'd be quite hard to actually then attack this particular part. Yeah. We want h of k of x to equal this. Okay, well let's just start with this. K of x is some kind of function. Okay, so it's actually probably easier to replace this with a variable and let the variable represent the function. Yeah. So maybe let z equal k of x. Yeah. So then h of z is equaling to 2x over x plus 1. Yeah. And then we just want to check on what the actual h of x function was, because I've completely forgotten. I think h of x was 2x minus 5 over x plus d. I think that's what it was, wasn't it? Yeah. So h of x is 2x minus 5 over x minus 2. Okay, so z feeds into the h function, and out needs to come 2x over x plus 1. Right, so let's feed z into the h function. So h of z equals 2z minus f over z minus 2, and that has to be the equivalent to 2x over x plus 1. So if you've got an equation to solve now, we've got to solve the equation for z, because z represents the function k of x. So I think a bit of cross multiplying. Does that look alright? 2z minus 5 into x plus 1 is equal to 2x into z minus 2. So this is 2x z minus 4x. Remember, we're trying to solve for z. And this is 2zx plus 2z minus 5x minus 5. Looks like the 2zx cancels on each side. And I can see 2z here. So a bit sorted out, and that's equivalent to negative 4x, bring the 5x across, that's positive x, and then positive 5. So all of this is pointing to the fact that z is equivalent to a half of x plus 5 in brackets, but z was a representation for k of x. So k of x is equivalent to a half of x plus 5. And that should do it.